Hey everybody, got a good one today. We're gonna be doing another video on the Makera Carvera Air. Specifically, we're gonna be exploring the fourth axis. I've never used a CNC with the fourth axis, so this is gonna be new to me and hopefully we'll all learn something. Today we're gonna be building a knurled knob out of brass. So we will be working in metal, we'll be building guitar parts, and I think we're gonna get a blast out of this project because we're not just gonna do any old knurl, we're gonna make a Van Dyke's Harms knurl. What's that? Take a look. So the first time I ever saw these really heavy knurled knobs was on the Lucky Dog Guitars website. And if you know Lucky Dog Guitars, they make fine Telecasters that are played by celebrities all over Nashville. And this is the actual image that I'm talking about. These really heavy knurled knobs that are basically pointy. They're almost like little pyramids sticking out, and I'd never seen anything like that. So after several years went by, I actually Googled this knob, and it turns out it's made by someone called Van Dyke Harms. And Van Dyke Harms specializes in very, very boutique hardware for guitars. Here is the knob that we're talking about here. It is basically almost like a star pattern, and it's a star pattern that's rotated for each layer. This is what I want to build. So let's get to it. Let's get to the design phase, and let's actually try to build, as best we can, one of these Van Dyke Harms Telecaster knobs. When I first designed this is how I designed it, with an 8-sided polygon. But this is incorrect because there are no flat sides on the Van Dyke Harms Telecaster knob. So each one of these sides is actually curved. So it curves and dips up to the points. So what I had to do was make arcs instead of lines for each one of these sides. And this is what it actually looks like. So instead of a flat surface between points, it's an arc between points. All we have to do now is take that and rotate it, and it'll look something like this. So once we have our two stars that are rotated properly, we can start extruding layers. And now this is where we start to have to make some guesses. How tall are each one of these layers? If we look at the reference photos, they're different. Notice how this bottom layer is much, much thinner than the middle layers. And then in the other reference photo, we clearly see that the top layer is much thinner. And the top layer has a loft that lets it gradually sweep into the actual flat top. So what I landed on was 3.9 millimeters for the middle layers, 2.7 millimeters for the bottom layer, and the top layer is 2.5 millimeters. And we clearly start building up till we get to our height. So I think it's 21 or 22 millimeters tall. So here's the top part, which lofts just like the actual reference image. So as you can see, each arc sweeps into the actual flat top and makes this beautiful, beautiful little kind of bevel. And the finished product would be like this, where we have the proper shaft diameter for a CTS pot. And then we have the recess, which needs to be deep enough to cover the washer of the pot and also wide enough to cover the washer of the pot. I do have the grub screw hole built into the model, and this is the proper diameter for us to be able to tap it by hand later. So here it is. This is my model of the Van Dyke Harms Telecaster knob. And look how sharp this thing is. So let's do one thing first. Let's 3D print this knob so we can actually see if everything works and fits. Meaning, will my CTS pot shaft fit in there? Will everything work? Is it the right height? I want to get an understanding of what this looks like in real life. So let's go ahead and 3D print it real quick. So the 3D print came out pretty good, and I'm happy with it. I think we can now move on to milling this. Here it is. What I was concerned about was the diameter to height ratio, and I think I got it spot on. The shaft works perfect for the CTS pot. So what is the recess? It covers the washer. It feels good in the hand, and the 3D printer did a great job. I'll make this design available on my store, so if anybody wants to 3D print their own, you'll have access to this. All right, let's move on to CNCing. All right, let's go ahead and unbox the fourth axis because I haven't opened it yet. So let's open this little guy up. All right, there's some instructions here. Oh, pretty. Looks like it actually came with some test material too. So these are those really cool epoxy tooling boards that are so easy to machine. And this is going to be a great method for kind of testing out to make sure everything works before we commit to actually milling on metal. So right out of the box, we get the 2 wrenches for actually adjusting the chuck, tightening and loosening it. But let's go ahead and get this set up on the actual Carvera Air. Now we just have to fasten it with some M5 20mm screws. These holes on the fourth axis align perfectly to the threaded inserts right beneath it in the bed. So already we'd have to do no cognitive thinking for setting this up. They do everything for us. So we're just going to put 6 screws in here and tighten everything down. Okay, so we're about to actually run the fourth axis on the Carvera Air, but we can't just start with brass because these are unknown tool paths to me. I've never run fourth axis tool paths. So we need a test. So I'm going to use this. This is Delrin. It is a machinable plastic that actually has pretty high ratings for temperature, meaning the high temperatures that the end mill creates won't melt this plastic. We'll actually be able to mill it and make chips. And it's soft enough to mill, it's soft enough to practice, also soft enough for us to run through the tool paths as fast as possible to test them. So the Delrin knob came out really well. The tool paths worked. So we have our tool paths, we know they work. Let's go ahead and start with brass and once again, kind of cross our fingers. All right, so I bought some bar stock. This is what we're gonna be using. And it's just the perfect length as well to fit between the tailstock and the headstock. So I can't complain for the price I got this. I think this was like $4 on Amazon. And I'm gonna be able to get 2 knobs out of this. If you consider that the original Van Dyke Harms knobs are $69 for 2 knobs. And I paid $4 for this bar stock. Yeah, I'm gonna get 2 knobs for $4. So pretty rad. It's not even halfway done. It's stunning. It's so beautiful already. Roughing pass is complete and I am very happy with this. It already feels nice and sharp. I have these 7mm posts here, so everything is nice and sturdy. So I feel like even without the finishing pass, this is a really unique design. This looks really cool. So it's got these kind of divots all the way around and it feels very textured. It looks super shiny. So even the finish on this looks great. And this is just a roughing pass. So if I wanted a unique design that was my own, I could actually stop right here. And this is a remarkable knob. So the trick was to use just a lot of passes. So I did the flat end mill and it did its pass. I did a ball end mill, it did its pass. Then I did a 0.5 millimeter engraving bit. It did its pass. Now this is the 0.2. And I'm able to do multiple passes and go as fast as I want. This is a 10-minute operation. It's already gone through 2 of the layers and it's got maybe 1, 2, 3 more to go. Look at this beauty. This is exactly what I was looking for. I didn't want a normal, traditional knurl. I wanted something that when you touched it, it hurt your fingers. This one is very sharp. I love it. And I never thought I could do anything like this. I never thought I'd be able to mill something like this. Not in a million years. Interesting thing is it was all done in Makera Cam. All the tool paths. I didn't do anything in Fusion because Fusion charges you $1,000 to take advantage of their 4th axis enhancement. They do offer a cheaper flex token plan, which is $300 for the year. That's ridiculous. I did all this in Makera Cam, and Makera Cam came free with the actual machine. I never thought I'd be able to do this. And this is straight off the machine. I thought I was going to have to hand finish this. I'm not going to. I'm just going to put this on the buffer and buff it to a shine once everything's done. But next steps are to put this on the bandsaw to take the tabs off. The knob came out so perfectly. And there it is on my shell pink telly with the single knob hole on the aluminum plate. So all machined on the Carvera Air. It's absolutely stunning. Turns perfectly. You get that nice little grip from those really sharp teeth. And you can polish it as much or as little as you like. I put this on the buffer and I got a very, very, very nice luster on the top. Getting in between all the little nooks and crannies is really, really hard. I don't know any machinist tricks for actually removing any of the machining marks or for polishing in those little tiny areas. So I'll have to actually do some research on those tiny little tools. It just looks absolutely gorgeous on my shell pink telly. The other really cool thing about this is that it's raw brass, so it'll patina with my fingers. So every time I touch it, all the oils in my hands are gonna make it sort of like a duller, more matte look. And so that luster will go away eventually, but I can always repolish it if I wanted to, or I can keep that patina, which is what I want. So the Carvera Air is a killer machine. I never thought I'd ever be able to machine anything like this, and I did. And it wasn't difficult. I did it in one weekend. One weekend. In fact, I would even say most of the machining was done in one day. And as far as the buffing, you spend as much time as you want on that part. If you want a high luster, you're gonna spend a lot of time. If you want it to just be sort of like raw brass, you can do that too, your choice. So the 4th axis on the Carvera Air really gets you up and running if you're interested in doing these kind of machining jobs, which I am. I've always wanted to build my own bridges, my own saddles, and I've never been able to really pursue that interest because I didn't have the right machine. And I didn't even bother designing any of that stuff. But now I am. I'm gonna be able to actually design bridges and saddles knowing that whatever I design, I can create the Carvera Air. I hope you enjoyed this video. Thanks for watching. Take it easy.